We've talked a lot about simplifying this entire semester. And one of the things about simplifying fractions with radicals is that you can't leave a radical in the denominator. If a number is not a perfect square or a perfect cube or a perfect root of some sort, we say that it's an irrational number. The decimal value, well, it's not even equals, it's approximately 1 decimal something. All of these numbers, square root of 2, square root of 3, square root of 5, they don't have a perfect integer root, so we say they are irrational. And we do not want an irrational number in the denominator. So you're always going to be asked to rationalize the denominator of a fraction. What we have to remember is that property that tells us that the root of a times the root of a equals a. Using that property, I can get rid of a square root in the denominator. I know all I have to do here is multiply root 5 times root 5. But remember, I don't want to change the value of my fraction. I want to create an equivalent expression. We do that by multiplying the numerator and the denominator by the same number. Of course, we know that root 5 over root 5 equals 1. This goes all the way back to week 1 when we were talking about regular fractions with an integer in the numerator and an integer in the denominator. If we wanted to create an equivalent expression, we have to multiply by 1. So now I can just multiply root 13 by root 5. That's root 65. Root 5 times root 5 is 5. This cannot be simplified further. The root 5 in the numerator is not the same as the 5 in the denominator. So be careful about that. Just like when we're multiplying, we can multiply numbers outside the radical sign with each other and numbers inside with each other. The same thing is true for division. You can't divide out a number inside with a number outside. Let's rationalize some denominators. Question 1. We have root 7 in the denominator. That means we need to multiply the numerator and the denominator by root 7. We have a number outside. It's got to multiply the 1 that we understand is outside the root 7. So 14, 11 times 7 gives us the root of 77 all over 7. Can this be simplified? Yes, of course it can, because I have a 7 and a 14 outside of the radical sign. That factor of 7 can come out. This equals 2 times the root of 77. Why don't you try question 2? You multiplied the numerator and the denominator by the root of 12x. In the numerator, I know that 12 can be simplified, so I'm going to prime factor. In the denominator, root 12x times root 12x equals 12x. 2 factors of 2, we can take them out. What do you notice? Yeah, we can simplify this fraction further. There's a 2 outside the radical sign and inside that 12 as well. What about the x? No, you're right. We cannot divide them out. The x inside the radical sign is not the same as the x outside. Their values are different. We should note here, of course, that x cannot equal 0, because if we had 6 times 0, this whole thing would be undefined. What about the 3 and the 6? No, because the square root of 3 doesn't actually equal 3. The square root of 3 equals 1 decimal something. Question 3, we want to rationalize the denominator. I know I have to multiply the numerator and the denominator by root 3. Remember to use the distributive property here. Root 7 times root 3, root 21. Root 3 times root 3 is 3. Can we simplify this? No, we cannot, because there's no common factor in the numerator. Even though I could write the root of 21 as the root of 3 times the root of 7, again, this root of 3 equals 1 decimal something. It's not a 3, it's a square root of 3. We cannot simplify it any further. Question 4 looks interesting. It looks like maybe you should simplify the numerator before you do any work. Pause your video and give it a try. By now you should have done so much practice that you knew you could simplify root 12 and root 8. We did that before we rationalized the denominator here. You didn't have to, but it's never a bad idea to simplify first. Oops, what's going on? There we go. Now we want to rationalize the denominator. We're going to multiply the numerator and the denominator by root 2. Remember, you have to use the distributive property. So we have 2 root 3 times 2. We're only going to multiply the radicals. And then 2 root 2 times root 2. Well, I know that root 2 times root 2 is 2. So 2 times 2 will give me 4 all over 2. This time I can see that 2 is common in the numerator. Do you see that? If I divide 2 root 6, I'm left with root 6. Divide 4. Now there's a common factor, because when we're multiplying, we have a factor and we can divide out the 2. This question simplified to root 6 plus 2.